So before we start this video, if you like this video, hit the like button. If you want to comment, then please do. If you want to share it, then please feel free to share it. And please make sure you subscribe so that you get all the latest tech news from this channel. That's great. Thank you. Now let's get on with the video. Welcome to this video tutorial where today we will be looking at Stub, Tottaly Stubby areas, and we'll do a quick overview of the topology, and then we're going to get straight on with the configuration work. So on the right is the topology we're going to use for this demonstration. Now we're going to be using commands from previous lessons to configure the aggregated Ethernet interfaces. So we have area 0, the backbone area, the normal area. Well, it is a backbone and a normal area. We have area 3, which is a normal area. And we have area 6, which we'll initially configure as a normal area. Then we're going to convert it to a stub and examine what happens. And then we'll configure it as a totally stubby and also examine what happens there with all the relevant show commands. Now, with regards to this IP network scheme, the interfaces are going to be as follows. So AE0 between R1 and R2 is going to be 192.168.1.0/30. The interfaces between R2 and R3 can be 192.168.1.4/30. The interfaces between R1 and R4 are going to be 192.168.1.8/30. And the interfaces between R4 and R5 are going to be 192.168.1.12/30. As already mentioned, now that we have the topology discussed, let's complete the core of this tutorial, which is the configuration work and examination of the config results. So here we are on router 1 at the configuration screen, and I've just completed a show configuration in the display set format so that you can see what's on there if you wish to copy this. So we're actually going to put in there the loopback 0 interfaces so that these addresses appear in the routing tables. So let's go ahead and do that. So the first thing we're going to do is we are going to go into edit mode. So we'll go into edit mode and we'll do set protocols, OSPF area, and remember this is area 0, so we do 0, 0, 0, 0, and we put in there the interfaces we require. So initially we're going to put in loopback 0.0 for unit 0. Then we're going to put in there AE1 and AE0. So let's put in there interface AE1.0 and 0.0, 0.0. Now we're going to commit this. So we'll commit this change. And we're going to have a look at any neighbors or anything that we have at the moment, which we shouldn't have. Okay, so we exit out of this. We're going to go back to operational mode and we'll do show OSPF interface. And it will show us the interfaces and it will say that we're waiting. Well, we're waiting for something on these interfaces, but we haven't configured anything yet. Show OSPF neighbors. And again, there's nothing. The only thing we will see something in is database. So if we do show OSPF database, and what we see in there is we see itself. Now we move on to router 2. Again, I've completed a very quick show configuration display set so that you can see what's going on. So remember, this router is in 2 areas. It's in area 0, the backbone, which is a normal area, and area 3, which is a normal area. So router 2, which lies in between, will actually be our ABR. So let's go ahead and configure OSPF on this system with the 2 different areas. So again, we go into edit mode and we do set protocols, OSPF area. We'll do area 0 first, so 0, 0, 0, 0, and the interfaces we want in this area are going to be LO0.0 for the loopback and AE0. So AE0.0. Now we have to look at AE1, which we know lies in area 3 because it connects ABR router 2 to router 3. So this is how we do that. So we do a set protocols, OSPF, but the area this time is 3, and we would do that with 0.0.3, and the interface we want in there is AE1.0. Now we can commit this, so we'll commit this. Now before we actually check the database, the neighbours and the interface, we're actually going to first of all go back to operational mode on this to prepare it, and then we're going to go to router 3 and configure that up first. So let's go ahead and do that now. So here we are on router 3, and again I've done a very quick show configuration with the display set command or option to show you the actual configuration as it is currently before we introduce OSPF. So let's go ahead and do that now. We'll set that up. So we'll go into edit mode and we'll do set protocols, OSPF area, and we're only in area 3 on this system, 0.0.3, and the interface is going to be loopback 0.0, and also it's going to be AE1, AE1.0. And we're going to commit this. So we'll commit this system. Now we're going to go back to operational mode on this one. And now we're going to go back to router 1 and see what our database, neighbours and interfaces say. So here we are back at router 1. So now let's look at our neighbours and interfaces first. So we'll do a show OSPF neighbour. Okay, and we see the neighbour with the IP address that's required for that particular neighbour and the interface it sees it on. So now let's have a look at the actual interface. So now we see the loopback, AE1 and AE0 with the area and the amount of neighbours. Well, there is only one neighbour because these systems at the moment are point to point, so we do not need to worry about the state DR, which as we know would be designated router. Even though it states it on here, it doesn't really matter on a point to point. So now let's have a look at the database and we will see what type of LSAs we have in the database. So if we do a show OSPF database, so what we have in here is we can see the different types. Okay, so we have the router LSAs, we have the network LSA, but now we have the summary LSAs. These will have been forwarded by the ABR as we note by the IP address. We know that this via the advertised router is our internal loopback address. So you also see that we have two summaries. This is the loopback address of router 3 that only exists in area 3. This is the network address that contains AE 1.0 of router 2 and AE 1.0 of router 3 because that has to be advertised as a summary. And you'll note that because there's two networks, there's two summary LSAs, as we mentioned in our previous lesson. If we look on router 2, we actually see more summaries. And the reason we see more summaries is because router 1, if you remember from the diagram, also has an AE1 interface that will be on the 8 network. And this is why we see this summary here. We also see the summary for the network that connects AE0 of router 1 to AE0 of router 2. Plus we see a summary on here of AE1's loopback address, which is a 32, so it is a network of its own. So this time you'll see there are 3 networks and 3 summaries, exactly the same as a previous lesson. And on router 3, we also see exactly the same being advertised and forwarded by router 2 because it is the ABR. So we see the summary of area 0's router 1 loopback address. We also see the local addressing of LSA type 1 and LSA type 2. So as per the previous lesson, we see 1s, 2s and 3s in these 2 areas. We now move on to router 4, and again I've done a quick show configuration display set. Remember, this router is going to be between area 0 and area 6. Now initially we're going to put area 6 as a normal area before we turn it into a stub and then a Tottaly stub. So the first thing we're going to do is we're going to set the OSPF on here. So we do edit and we do set protocols, OSPF area 0000, and the interfaces that we want to put into 0 are going to be LO0.0, and we need the connection between router 1 and this router, which is AE1. So we set in there interfaces AE1.0. The second interface we have to configure is area 6 interface of AE0. So we'll go ahead and do that now. So we do set protocols, OSPF area, and this time it's 000.6. And the interface we are going to put into area 6 is AE0. So we do AE0.0. And we can commit this interface. So we've committed the changes. So before we have a look at anything, we'll exit on this back to operational mode, and we will configure up router 5 into OSPF as well. So here we are at router 5, and again, show configuration in display set for you to have a look at the config that's on this system. So we go into edit mode, and we do set protocols, OSPF, area, and we want area 6. So we do area 6, and the interfaces are going to be loopback 0 and AE0. So we pop those interfaces in there, and we will do a commit on this system. So that's the commit complete, and we'll exit this system back to operational mode. Now let's go back to router 1, and we'll have a look at the LSAs and the other information that is on router 1 now that we have applied OSPF to router 4 and router 5. So the first thing we notice when we do the neighbours is that we now have router 4 as a neighbour with its ID of its loopback interface, and this is how we know it's router 4, and we know router 2 because of its locally connected interface to router 1. So now let's have a look at the interfaces. So we do show OSPF interface, and we now see again the local loopback AE1 and AE0 as we noted previously. Now we're going to have a look at the LSAs that are showing up in the database. So we do show OSPF database. Now we have all the networks, and we have 4 summaries now. So we have router 3, router 5, plus the 2 networks that attach those systems. So we have 4 summaries, 1 for each network being advertised. This is exactly what we want to see. So we see our LSA type 1s, our LSA type 2s, and our LSA type 3s. Now let's have a look at the database on router 5 and see what we have showing up there from an LSA perspective. So we do show OSPF database. And we have all the summaries listed from router 4, which is the ABR. So it's one summary for every network that exists. So we have a network by itself of the loopback of router 1, the loopback of router 3, and the loopback of router 4. We also have the summaries for the network that connects router 1 to router 2, the network that connects router 2 to router 3, and the network that connects router 1 to router 4. And these are the summaries we expect to see. And within this area, we also see the type 1s and the type 2. To create the stub area, we're going to start with router 5, since all the interfaces are within the area 6 that we are going to turn into the stub area. What do we need to do on router 5 to ensure that it becomes a stub router? And by the way, it's very important to note this. The reason that every router within a stub area must be configured with the stub command is simply because a stub router cannot communicate with a non-stub router. So let's go ahead and configure that. So we'll go into edit mode, and it's this simple command: set protocols OSPF area, and we know it's 6, so 0006 stub. And that is it. That is the command. Before we commit this command, we're going to have a quick look at the OSPF routing table. So we will do a run show OSPF route. And you'll note we have all the routes there currently. So now let's commit this command. And now let's have a look at the routing table again. Now you'll note that we only have the intra-area routes now showing. Okay, we cannot see any externals. So what we have to do is we have to ensure we also configure the ABR, which is router 4, which we'll go ahead and do now. Before we configure router 4 to participate in the stub, the interface that is within the stub area, I just need to make this quick point first, okay, about the metric that's required for the default route. And this is required before the ABR will advertise a default route into the stub area. Now, once we've configured that, the ABR will advertise the default route in place of the external routes. As we know, they're the LSA type 5s that are not allowed into a stub area. And that's why they're not being advertised into the stub area. Remember, back to that previous lesson, this is so routing devices in this particular area can reach destinations outside the area. Now, the default metric is 1, but what we're going to put here is we'll just put it as 10. Okay, and again, it's quite a simple command. So we just do a set protocols OSPF area 0006 stub with a default metric of 10. That's what we're going to pop in there. And we're going to commit that. Now it's committed, we're going to go to router 5 and have a look at the routing tables now. If you remember, before we made the configuration changes on router 4, this was what our routing table looked like after we had converted it to a stub. This is what it looked like before it was converted to a stub, and it was a normal area. So let's have a look and see what it looks like now. So now we can see all of our networks back again. Okay, and we have, because of the LSA type 5s, and don't forget it's going to add the 1 to the metric because of the default. That's why we see a metric of 11. But we did not configure this default route. This default route has now been injected into the stub area in place of the not allowed LSA type 5, so that this router now will know how to get to the outside world via this next hop address. We notice when looking at the routing table of router 5, the OSPF routing table, that we still see our summaries. We can see those here, okay? Remember in the previous lesson we said that we could reduce all those type 3s, or in fact just have the one type 3, which would be this default route. We really don't need the summaries in there. So let's go ahead and turn this into a totally stubby area where we do not have the summaries being advertised. This again is completed on the ABR, which is router 4. So we'll go to router 4 now and show you how to do that. How do we create a totally stubby area? Again, it's very, very simple, very straightforward. We don't want the summaries in there, so let's see how we do this. So we simply do a set protocols, OSPF, our area, which is 6. So we put area 6, we use the stub command, and then we'll do the question mark and we'll see what options we have. Remember, we don't want summaries in there. So there we go, there's the command, no summaries. Don't flood summary LSAs into this stub area. So let's use the no summaries command. And we're going to commit this. Now it's been committed, let's go back to router 5 and have a look at the routing table again. Here we are back at router 5 and we see all of the summaries and the network prefixes that we had before. Let's now complete another show OSPF route so that we can see what we have in the routing table now. So we'll do show OSPF route, and straight away you'll notice that all the summaries have disappeared. Now the important part to note here is, do we still have communication from this totally stubby area to the furthest away router's loopback address? The furthest router away is router 3 with a loopback address of 3.3.3.3. So let's see if we can still ping that. The answer is yes, we can still ping 3.3.3.3, which means we have external access to all of our area routers and networks. If we have a look at the show OSPF database on router 5, we'll notice now that we only have the one summary, which is LSA type 3. All the others have now disappeared because they are no longer required, and we have turned this into a totally stubby area. So we'll go back to the presentation now and we'll just quickly summarize this and end this tutorial. To quickly summarize, all routers in a stub area, as it states here, must be configured with stub command. As I noted during the configuration work, that is because a stub router cannot communicate with a non-stub router. The ABR, the area border router, must be configured with the default metric to ensure the default route is advertised into the stub area. If it's not configured, then the stub area won't get the default route. The default for the metric is 1. To create the totally stubby area, we have to configure the no summaries command on the ABR. That concludes the demonstration of how to configure a totally stub area. Hope you enjoyed the video. Please hit that subscribe button so that you get more videos like this from a very high level and low level perspective. Thank you for enjoying the video. Bye-bye.